Okay, we're going to take a look at chapter 3.1, functions, but in this case we're going to look particularly at situational graphs. Alright, so as you see, you have graph A, B, and C, and it's time in hours versus rainfall. Now, a couple of words that you need to understand is independent and dependent. Okay? Independent and dependent. Now, time and hours are your independent. Okay? That's your time. And your dependent is the rainfall. So your the rainfall, the amount of rainfall is dependent on how long it is raining for the day. So I just want to start using those vocabulary words. That way you can start utilizing them as well on your tests and quizzes and just everyday conversations in class. All right, so we're going to take a look at the 3 days in September. Atlanta received the same amount of rainfall. Now notice this dashed line means that this is the amount of rainfall that they all received, all right, or those 3 days received. On September 8th, 19th, and 27th. On September 8th, it rained very hard during the morning. That means the amount of water increased rapidly since it's raining really hard. But then it dies down a little bit as the day goes on. So it's going to increase really fast, and then it's going to tail off. On September 19th, it rained steadily. So there's a key word right there. Steadily would refer to as a constant rate. Okay? A constant rate. So look at the graphs. Which one do you think would relate to a constant rate? And then on September 27th, it rained lightly during the morning. So that means in the beginning, there was only a little bit of rain. So the rainfall, the amount of inches of rainfall would be very small. But then, as the day continued, it rained heavily. So that means it's going to quickly fill up. So if you look at A here, this never wavers. It stays at the same rate the entire day. So as this increases, so as time increases, the rainfall increases at the same rate. That's the second scenario, so that's B. Then, I'm sorry, that's A. So that's this one right here. Now on B, notice the amount of rainfall. This is the amount of rainfall right here. The amount of rainfall is very little. So very little rainfall. Then all of a sudden, let's say 1, 2, 3, 4. As the day starts continuing, notice how the amount of rainfall starts to increase and then really starts to grow. That one is the third one. So it rained lightly during the day and then increased heavily in the evening. Whereas the last one, notice the amount of rainfall is really collecting very, very fast. So that is the first scenario where it rained very hard in the morning. So notice in just a couple of 2 or 3 hours, we have almost the full amount of rainfall for the day. But then it just kind of tails off and doesn't rain anymore. So that would be the first scenario. So make sure you read through these scenarios and kind of look for keywords that help determine what's happening to the graph at certain intervals. Okay, now going back to the rainfall versus time, the question is, could a graph of rainfall throughout the day ever slant downward? In other words, could it ever look like this? And I guess depending on your imagination would really determine whether or not this could happen. So if you look at this, as time would increase, your amount of rainfall would have to decrease, okay? Almost to zero as it approaches zero here. Well, if it's raining throughout the day, your rainfall would actually be accumulating. So if you think of it in that format, your rainfall, the amount of rainfall that you would collect should never be able to decrease. Because if it's constantly raining, you would only have an increase. Finally, on this last one, the pool in a community park is being filled for the summer. Okay, well that's not unusual. A water truck arrives early in the morning, but no water is put in from it into the pool for at least 1 hour. So it's automatically telling you, hey, it's there at the park, but no water is going in it. And now, how long? Well, for 1 hour that truck parked there. So that means there's no at 0 or at 1 hour there's zero amount of water in the pool. But then it says because a small repair must be made to the pool first. So apparently they made the repair right here in that first hour. Then the spigot. Now, if you don't know what a spigot is, that's basically the opening for the valve on the water truck is then opened partially. So you can imagine them turning the spigot and water start to flow into a pipe or a tube into the pool. So now it's going to add water gradually. Well, that means at a very slow rate. Very, 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 very slow rate. Now, but look how long it says. It's going to add it to the pool for the next 2 hours. Well, if it's going to do it gradually, they're not going to be going very fast. So look at, this is the water level. The more water you add to it, the higher it gets. But it's going to do it for 2 hours, so they're going to end right here. So it's going to increase it slightly. All right, so it might get, depending on how we measure the water level, it might get to about right here. So again, at a very slow, gradual pace. Then look at question B. It says the workers determined that the repair they made to the pool is working. So apparently, this little time frame is just to see whether or not that repair is going to hold. Then look what they did. So once they determined that the water is going to hold, they completely opened the spigot and continue filling the pool. Well, if they open it up all the way, that means that water is going to be rushing into the pool. Well, then you're going to quickly see a rise in the pool. So this should increase rapidly. So you might see this type of graph, and it depends on how it goes into the pool. It might be even faster than that. It might be a higher rate. So it could increase maybe like this if it's at the same rate. So if they open it up all the way, it should be coming all out at the same rate. So actually, we could actually erase this and put in, if it's coming out of the truck at the same rate, it actually would be at a steady pace, but much quicker. And so it'd fill up the pool quicker. And that right there is a couple of things you need to be aware of whenever you're working with word problems with functions.